This lesson AMU1L9 on rational equations. The word rational means you're going to have fractions. Equations mean there's going to be an equal sign and you're going to be solving. And just like the last section, there's not going to be any new concepts here. It may just be a new way of applying it. So there's two methods. You can either use the proportion method or you can use the least common denominator method. Now the proportion method is the easier method if you have just one fraction on each side of your equal sign. Like this one, you have a single fraction on the left and a single fraction on the right. So the easiest thing to do here is proportions, which is cross multiply and solve. So what we're going to do here is multiply, cross, and then solve. So I've got 4 times v minus 4 is equal to 10 times v plus 3. And now we're just going to solve. 4v minus 16 is equal to 10v plus 30. Then I would subtract 4v from each side. So I have negative 16 is equal to 6v plus 30. And then I'm going to subtract 30 from each side. So now I have negative 46 is equal to 6v. We're going to divide both sides by 6, and I'll come over here to simplify. So v is equal to, it's going to be negative, and both of these will reduce down by 2. So that would be 23 over 3. And just like with the other section, you'd want to fill that in and make sure that it works. Number 2 is t plus 2 over 2t minus 1 is equal to 5/4. Once again, I have a single fraction on both sides of the equal sign. So the quickest way, the best method for this one is going to be using proportions. So I'm just going to multiply 4 times t plus 2 and 5 times 2t minus 1. Then I'm ready to distribute and solve. So I've got 4t plus 8 is equal to 10t minus 5. Let's subtract 4t from each side. So now I have 8 is equal to 6t minus 5. Add 5 to each side and I get 6t is equal to 13. Divide both sides by 6 and t is equal to 13 over 6. It will not reduce. Check to be sure. And there's your answer. Okay, for number 3, we've got d minus 2 over 7 equals 7 over d minus 2. Once again, analysis, I see a single fraction equals a single fraction, so the proportion method is going to be the way to go. So let's cross multiply and solve. I've got d minus 2 times d minus 2 equals 7 times 7. Let's go ahead and do 49. All right, 2 binomials multiplied together. You're going to FOIL it or use the distributive method, however you want to term that. So we're going to have d squared minus 2d and minus 2d is going to combine to minus 4d, and then negative 2 times negative 2 is positive 4. Okay, now to the solving. You see that quadratic term, so you know you're going to use one of your quadratic methods. Zero product property, if we can, so we need to factor. Before we do, we need a 0 over here. So let's subtract 49 from each side. So this gives us d squared minus 4d. 4 minus 49 is minus 45. Okay? Now we're ready to factor. This is a minus, so we're going to have d and d, plus and minus, a pair of numbers that multiply to give you negative 45, but add up to give you negative 4 is 9 and 5. So we're going to do d plus 5 equals 0. Therefore, d is equal to negative 5. And d minus 9 is equal to 0. Therefore, d is equal to 9. So your answer set is negative 5 and 9. And yes, check them, be sure they work. I did, and they do. And number 4, 2b minus 5 over 2 equals 4b minus 1 over b plus 6. Once again, we have single fraction equals single fraction, so you definitely want to choose the proportion method. So 2b minus 5 times b plus 6 equals 2 times 4b minus 1. And we are ready to distribute and solve. So here, 2b times b is 2b squared, and 2b times 6 is 12b. This will be negative 5b and negative 30. And I can go ahead and combine this. So I've got 2b squared plus 7b minus 30 equals, all right, over here, I'm going to distribute, and that's going to be 8b minus 2. Once again, I see that quadratic term, so I know I'm going to need, I can factor, hopefully. So let's get a 0 here. I'm going to subtract 8b and add 2 to both sides. So this is going to give me 2b to the second minus b and minus 28 is equal to 0. All right, now to factor this one is a little bit more difficult because it does have a coefficient. So you would want to pull out that old AC method and find the pair of numbers, go through that whole ordeal. So this will factor into 2b times b plus and minus, and we are going to use 7 and 4, okay? All right, now we're ready to set each of these up, set equal to 0, and solve. So 2b plus 7 equals 0, and b minus 4 is equal to 0. So let's solve. Subtract 7. 2b is negative 7. Divide by 2. b is negative 7/2. Here, b is equal to 4. So your solution set is negative 7/2, positive 4. Fill them in, and they both check. Okay, for number 5, you got 1 over 10 minus 2 over 5 equals p minus 5 over 5p. We do not have a single fraction here on the left. You have an expression. So we can't use the proportion method right off the bat. Now, you could combine these two fractions, and then when you combine them, you can use the proportion method. Or this would be a good opportunity to show you what the least common denominator method looks like. Look at your 3 denominators and pick out a least common denominator. Between 10 and 5 and p, your LCD is going to be 10p. You need one of everything and the highest power of each one. So here's what we're going to use. If you multiply all the way through by a least common denominator, you get rid of all the fractions. So I'm going to come over here, I'm going to take a minute, and I want to show you what this looks like for every single one, because I have to multiply all 3 of these times 10p. Now if I take 1 over 10 and I multiply that times 10p, look at what happens. You get 10p over 10, your 10s cancel out, so you just have a p, okay? So the first one, when I distribute here, that's where this p came from. All right, now let's do 2/5 the same way. If I take 2/5 times 10p, what do you get? Well, you have 20p over 5. These cancel out to 4, so now you have 4p. Now when I take this fraction, p minus 5 over 5p, and I multiply it times 10p, what happens? Well, this is actually all 1, so the p's cancel out. 5 will go into 10 2 times, and then this 2 can distribute into there, and we can do that in one step. So 2p minus 10. Now you see what multiplying by a least common denominator all the way through an equation does to it. It gets rid of all the fractions. So now let's just solve. P minus 4p is negative 3p. Then I'll subtract 2p from each side. So now I have negative 5p is equal to negative 10. Divide both sides by negative 5, and p is equal to 2. You can plug it in, gets the right answer, so that checks. Okay, number 6, y plus 1 over 4y is equal to 1/4 plus y minus 2 over 2y. So once again, we do not have a single fraction over here on the right-hand side, so we're going to go with method 2, which is using the least common denominator. So between 4y, 4, and 2y, our least common denominator is going to be 4y. So I have to multiply this times all three of the fractions. Now when I multiply it times this first one, those two are going to totally cancel out. So I just have y plus 1. All right, when I multiply 1/4 times 4y, the 4's cancel, so all I have is y over 1, which is just y. Now when I multiply 4y times y minus 2 over 2y, well, the y's cancel. 2 will go into 4 2 times. And then I'm going to distribute that 2 into that binomial. So you've got 2 times y is 2y and minus 4. All right, now you see that was a little bit of a headache, but it got rid of all the fractions. And so you just have a simple linear equation now. Let's simplify that right-hand side. Y plus 2y is 3y. And then, now let's subtract y from each side. So I have 1 is equal to 2y minus 4. And then let's add 4 to each side. So 5 is equal to 2y. Divide both sides by 2. And y is equal to 5/2. And it does check. Okay, number 7 is here, and we look at these. I do not have a single fraction over here on the left, so I can't use the proportion method. I'm going to use least common denominator. So I look at my 3 denominators. First, look at the numbers, 6, 3, and 2. What will all 3 of those numbers go into? 6. Remember, your lowest common denominator has to be at least as large as the biggest number that you have, because that has to go into it. All right, now what variable do you have? You have an r, and what is the largest exponent of r that you have? Squared. All right, so what we want to do is we're going to multiply 6r squared times all 3 of these. And when I multiply it times this first one, your 6r squareds cancel out, and all you have is r minus 3. All right, now here, when I multiply 1 over 3r squared times this, all right, what happens? 3 goes into 6 2 times. The r squares divide out to 1, so what you actually have left is 2. All right, now to do 5 over 2r times 6r squared. Your 2 goes into 6 3 times. Your r goes into the r squared and leaves r left over. 5 times 3r is 15r. And like I said, I know that's a headache, but now you're done with all the fractions, so the rest of it's just easy. Okay, over here, minus 3 plus 2 is 1. Then I can subtract r from each side, so I have negative 1 is equal to 14r. Then I want to divide both sides by 14, so r is equal to negative 1 over 14. Filling it in, yes, it checks. Okay, here's problem number 8, and we see over here we do not have a single fractional term, so let's go with the LCD method. We see we have a 6, a 6k squared, and a 6k squared. All right, so the least common denominator here is just going to be 6k to the second. Everything, every denominator will go into that denominator. All right, when I multiply 1/6 times 6k squared, your 6's cancel out. K squared times 1 is just k squared. All right, now, when I multiply this times 6k squared, those two cancel out, and all I'm left with is k squared plus 9k plus 20 equals. All right, over here, same thing happens. This cancels with this, so all I'm left with is the denominator. And now I see quadratics, so let me simplify this. This is going to be 2k squared plus 9k plus 20 equals 2k squared plus 11k plus 15. Now, since it's quadratic, I need to get everything over here. So let's start with the k squares. Now, when I subtract 2 to get rid of this, it's also going to get rid of it over here, which makes it really nice. Now, what I have is 9k plus 20 is equal to 11k plus 15. So let's subtract 9k from each side, and that's going to give me 20 is equal to 2k plus 15. Subtract 15 from each side, so that's going to give me 5 is equal to 2k. Divide both sides by 2, so I get k is equal to 5/2. Okay, let's look at number 9. Once again, we have more than one fraction. We have 2 fractions over here, so we're not going to use the proportion method. Now, when we get ready to look for a least common denominator on this one, it's a little more difficult. Before you can find a least common denominator, you need all of your denominators factored. Now, in the other ones we worked, it was like 6 times something, so it was just a monomial. You didn't have to factor it, but here, it's a polynomial, so we're going to have to factor it. Here, m squared minus m, that will factor into m times m minus 1. M minus 1 is already as factored as low as it'll go. And then over here, once again, m times m minus 1. Now to find our least common denominator, we want one of every factor. So what do we have? We have an m and we have an m minus 1. Does that cover everything? Yeah. So now we're going to multiply this times all 3 of these terms. Well, let's see what happens. When I multiply it times this first term, the whole thing cancels out, so I just have a 1. Now, when I multiply it times this second term, only the m minus 1's cancel out, so I still have to multiply that m times 1. So that's going to give me m. And then over here, the whole thing cancels out again, so I just have that numerator. Now, I know that was a headache, but look how easy it is now. All you're going to do is subtract 1 from each side, and m is equal to 5, and you can check that, and yes, it works. Okay, number 10, once again, I do not have a single fraction over here, plus I have a whole number over here. So I'm going to take care of that first of all. If you have a whole number in here, just put it over 1. Now, I can use the least common denominator method on this, but you know what? And this is a lot of if-thens at this point. If you see something that'll work better, go ahead and use it. And what I see right here is that these 2 fractions have the same denominator. So when you have a common denominator, you can just combine numerators. So what I actually have here is 3 minus x plus 1 over 5x plus 1 equals 1 over 1. And then I'd go ahead and simplify this. So it's going to be 3 minus x. Now this minus distributes in there. So minus 1 over 5x plus 1 is equal to 1 over 1. 3 minus 1 is 2. So you've got 2 minus x over 5x plus 1. And a lot of that you probably would have done in your head. I just didn't want to lose anybody. So now we're ready to cross multiply. Since you are just multiplying by 1 on both of them, what you're going to wind up with is 2 minus x equals 5x plus 1. And then we're ready to solve. Add x to each side, and you get 2 is equal to 6x plus 1. Subtract 1 from each side. 1 is equal to 6x. Divide both sides by 6, and x is equal to 1 over 6. Okay, number 11, once again, we don't have a single fraction over here, so we are going to want to go with the LCD method. All right, what are our least common what are our denominators? We've got a 2 and an s and a 2s. So the lowest common denominator for all three of those things, you take one of everything and the highest power of each one is just going to be 2s. That's your least common denominator. So we're going to multiply that times each one of these things. Now when I multiply 1/2 times 2s, what happens? It's 2s over 1. The 2's cancel out, so you got 1 times s, s over 1 is just s. So this times 1/2 just gives you s. Now when I multiply 2 over s times 2s, let's look at what happens. The s's cancel out. I'm left with 2 times 2, which is 4. Now when I multiply 2s times this one, the 2s's cancel out totally, but be careful because this is a minus sign, and before I can just bring this down, this has to be distributed all the way in here. So that's going to give me a minus s squared, a plus 2s, and a plus 8. All right, let's combine terms and rearrange here. I've got that negative s squared. 4 plus 8 is 12, but let me put the 2s in the middle. So this is what I have. Now, since this is a quadratic, I'm going to need a 0 here. So I'm going to add, I'm going to add s squared. I'm going to subtract 2s and subtract 12. That's going to move all this stuff over here. So now I have s squared, and because I added s squared here, when I subtract 2s from here, s minus 2s just gives you minus 1s. And then you bring the minus 12 over, so you have 0. Okay, now let's factor. What will factor into this? This will factor into s plus 4. Nope. S minus 4 times s plus 3. Okay, negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. And now we're just going to solve. S minus 4 is equal to 0. S plus 3 is equal to 0. So I get s is equal to 4, or s is equal to negative 3. So my answer set is negative 3, positive 4. And if you plug them both in, you will find that they check. Okay, here's number 12. First of all, I've got a W over here, and then I have these two fractions here, so I can't use the proportion method right off the bat. Now, true enough, these do have the same denominator, so I could combine, but that looks like it's going to get kind of messy anyway. I'm just going to go ahead and get rid of all the fractions by multiplying all the way through by the common denominator, which is W. They're both W's. Now, W times this W is going to give me W squared. When I multiply 1W times W, the W's cancel out, and I just have 1 left. Now, when I multiply this, the W's also cancel out, but I have to be careful because I need to distribute that minus all the way through there. So that is going to give me 1 minus 2W squared plus 10W minus 8. Okay, let's go ahead and combine the 1 and the minus 8. and that is going to leave me negative 2w squared plus 10w minus 7. Okay, so now I see this quadratic, well, both of them, so I know I need a 0 here. I'm going to move all of this over here because that's going to change this, which is going to be my leading term because it has the I is to exponent. If I move it over by adding 2w to each side, then it becomes positive. So now I have 3w squared there. Then I would want to subtract 10w from each side and add 7 to each side. So I have 0 here and all my things are now. Okay, quadratic will need to be factored, and this will factor into, let's see, I'm going to have to use the AC method on that. So that's going to factor into 3w minus 7 and w minus 1. Okay, you can check back on lesson 2 if you need more help with the AC method. And then we're going to take each one of these and set it equal to 0. So now I have 3w minus 7 equals 0 and w minus 1 equals 0. Let's just solve. Add 7 to each side, so 3w is equal to 7. Divide both sides by 3, so w is 7/3. Or add 1 to each side, w is 1. So your solution set is going to be 1 and 7/3. Fill them in, check them out, they both work. Okay, number 13 is a little intense just because of the least common denominator thing, but that's okay. We're just going to go slowly and try not to make any careless mistakes. Since I have two fractions over here, that's what lets me know I have to use the least common denominator method. Before I can use that method, I have to be sure that every denominator is fully factored. All right, this z minus 5 is factored. It can't factor anymore. And this 2 is also factored as low as it can go. Now, this can factor, and we would unfoil it, and that's going to go into z minus 5 and z minus 2. All right, so I look at all of these things. I want to be sure that I have one of everything. So my LCD over here is going to be the z minus 5 and the z minus 2 and the 2. This 2 is not the same as the z minus 2. Okay, so that's why I need another one. Now, I'm going to multiply these three terms times each one of these fractions and see what happens. All right, when I multiply, and I'll come over here, if this was my scratch paper, if I multiply 1 over z minus 5 times this whole thing, z minus 5, z minus 2, and 2. Let's see what we have left, and this would all be over 1. So, the z minus 5 would cancel. Then I have 1 time, and the 1's cancel if you want to look at it that way. Here, I've got to distribute this 2, so I'm going to get 2z minus 4. All right? That is what happens when I multiply this fraction times that least common denominator. So I can just rewrite this as 2z minus 4, and I'm ready to move on. Okay? Now, for the next one, when I multiply this times all of that, what would happen if I do that? 1 over, and I'm going to write it in factored form, z minus 5, z minus 2 times, and this is z minus 5, z minus 2, and 2. Okay, the 1's cancel, the z minus 5's cancel, the z minus 2's cancel, so what do I have left? Just a 2. So I can just come over here and put 2 minus. All right, now I've got to do the same thing with that 1/2. So I'm going to multiply 1/2 times all of this, z minus 5, z minus 2, and 2. So the 2's cancel, the 1's cancel, and what do I have? And that should have been a minus 2, okay? Now, before I move that over here, let's go ahead and multiply these two things together. So z minus 5 times z minus 2 is going to give you z squared minus, all right, minus 5 minus 2z will give you minus 7z. And then negative 2 times negative 5 will give you positive 10, okay? Now, this is where you have to be careful also, because you are bringing it over here to be behind a minus sign. So we want to be sure that we consider that, because next we'll need to distribute. So we're going to leave this side like it is for now, 2 minus. All right, that's going to be minus 2z, a plus 7z, and minus 10, okay? 2 and minus 10 can combine, so now we have 2z minus 4 is equal to negative z squared plus 7z minus 8, okay. Where we are now is we see a quadratic term, so we know that we need a 0 over here and everything else, and then we can factor and use the zero product property. All right, I'm going to add z squared to each side. I'm going to subtract 7z from each side, and I'm going to add 8 to each side. So when I do all that over here, that's going to give me z squared. And then that minus 7z will give me minus 5z when I combine it with the 2. All right, when I bring that plus 8 over, negative 4 plus 8 is positive 4. Okay, and let me come over here so I'll have some more scratch room. All right, what will this factor into? Well, it's going to unfold into z minus 4 z minus 1 is equal to 0. And then I would take each factor, z minus 4 set it equal to 0, z minus 1 set it equal to 0, so I get 4 and 1. And if you fill that in to your original, you will see that they both work. Okay, number 14, the last problem. So once again, we can't use the proportion method. We're going to have to use LCD. So let's factor all these denominators. Now when you factor, the first thing you do is take out a greatest common factor. So the greatest common factor here is u squared. So that's going to leave you u plus 1. U plus 1 here is factored form, and u squared is factored form. Okay, for my LCD, I want to take one of everything. So I start with this. I've got u squared and I've got u plus 1. Now, does this denominator have anything that I don't already have? No. And the same thing with this one. So that is your LCD. Now we are going to multiply this times all three fractions, keeping in mind that this is a minus sign, you know, in case that makes a difference, which it will. So when I take this first one, the 1 over my factored form, u squared times u plus 1, and I multiply it times the common denominator over 1. These cancel, you got 1 over 1, which is just 1. So all of this times that reduced to 1. All right. Now let's do the same thing with our second one. But we're going to have a minus. Don't let me forget what my LCD was. U squared times u plus 1. Okay. Now when I multiply this one, which is 1 over u plus 1 times u squared times u plus 1 over 1. This cancels out. This makes 1. So what am I left with? U squared. So when I multiply it up here, or when I put it here, I've got u squared. All right. Now over here, I've got to do 3 over u squared times u squared u plus 1 over 1. These two things cancel out. The 1 in the denominator is not necessary. So let's go ahead and distribute that 3 times u plus 1, and that's going to give you 3u plus 3. So now I have 3u plus 3. Okay? So let's start solving. I see my quadratic term here, so I know I need to get everything on one side or the other and 0 on the other. Now, since there's a minus sign in front of my quadratic term, I'm going to choose to move it over to the other side, because then I can add it and that will make it positive. Okay? Now, got rid of those. So what do I need to do to the 1? Well, I'm going to subtract 1, and now I have 0 here. I've got to subtract 1 over here to keep it balanced. So nothing changed about the 3u, and that's a plus 2. Okay? So now let's factor. I have u plus 1 and u plus 2. Those will factor this. And now I'm ready to use my zero product property. So I have u plus 1 is equal to 0, u plus 2 is equal to 0. So u is equal to negative 1, and u is equal to negative 2. And those are my possible answers. Now, when I go back to fill those in to check them, there's a problem. The negative 2 fills in and it checks just fine, but look at this negative 1. What's going to happen when I fill negative 1 into this fraction? What's that denominator going to be? 0. That is undefined. So this does not work. And I call your attention to this because all the other ones I didn't show you where I had checked it, but I did. And like I said, when you're on your own working a problem, you need to check those. Well, anytime a number makes one of your denominators 0, that's undefined. And when you need to look for that is when you have your variable in the denominator. That's what always catches my eye. If there's a variable in my denominator, I stop and ask myself what would make that 0, because that's going to be left out. So the negative 1 does not work. The negative 2 does. That was a very intense problem, and y'all did a great job. So thanks.